Hello, in this lecture we will find the value of x using two different methods. In the drawing we have right triangle, triangle ABC, angle ABC equals to 90 degrees, angle BAD, this angle equals to alpha, angle DAE equals to alpha, and this angle EAC also equals to alpha. And we also know that BD equals to 3 units, DE equals to 4 units, and we want to find out the value of AC, that is x. Okay, so first of all I will present to you the angle bisector theorem. So what is angle bisector theorem? Actually, if we have triangle ABC, and AD is angle bisector, AD is angle bisector in triangle ABC. That is to say, AD divides angle BAC to two equal parts. If this angle is theta, then this angle will be also theta. Okay, so angle bisector AD divides angle BAC to two equal parts, theta and theta. So according to angle bisector theorem, an angle bisector divides the side it hits in a ratio that equal to the ratio of the angle legs. I will read angle bisector theorem again. Angle bisector theorem states that an angle bisector divides the side it hits in a ratio that equal to a ratio of the angle legs. Okay, so actually the meaning of angle bisector theorem is that the angle bisector AD divides side BC. It's angle bisector AD, it's side BC in the triangle, and it divides it in a ratio that actually it is DC over BD, DC over DB. DC over DB is the ratio that angle bisector AD divides side BC of the triangle, and that ratio, according to the angle bisector theorem, that ratio equals to the ratio of the angle legs. It equals to the ratio of the angle legs, and the ratio between the angle legs is actually AC over AB. Okay. Again, angle bisector AD divides side BC in a ratio that equals to DC over DB, and that ratio equals to the ratio between the angle legs. The angle legs are AC and AB, and the ratio between the angle legs is AC over AB. Okay, so we can implement the angle bisector theorem in our drawing, because we will focus on triangle, the right triangle, triangle ABE, and in the right triangle, triangle ABE, actually AD is angle bisector. AD is angle bisector. Again, in the right triangle, triangle ABE, AD is angle bisector. Why AD is angle bisector in the right triangle ABE? Because of the fact that it divides angle ABE to two equal parts, to alpha and alpha. Therefore, AD is angle bisector in triangle, the right triangle ABE. Therefore, according to angle bisector theorem, angle bisector AD divides side BE in a ratio of BD over DE, and that ratio equals to the ratio between the angle legs. The ratio between the angle legs is AB over AE. Okay, so we got that BD over DE equals to AB over AE. Again, the angle bisector AD divides side BE of the triangle ABE in a ratio of BD over DE, and that ratio equals to the ratio between the angle legs. The angle legs are AB and AE, and the ratio between the angle legs is AB over AE. So the ratio between the angle legs is equal to the ratio that angle bisector AD divides side BE, that is to say to BD over DE. Okay, so BD over DE equals to AB over AE. And we know that BD equals to 3 units, so we'll substitute BD by 3, and DE equals to 4 units. So we got that AB over AE, AB over AE equals to 3 over 4, because BD equals to 3 and DE equals to 4. Okay, so here we will define AB as 3K. AB equals to 3K according to our definition, and we will find out what is the value of AE if AB equals to 3K. So we will substitute AB in this equality by 3K, and we will find out the value of AE. So we get here that 3 over 4 equals to AB is 3K over AE. Here we will multiply this equality by AE, and we will get that 3 over 4 times AE equals to 3K So we multiply this equality by AE, and we got that three over 4 AE equals to 3K. Here we will multiply this equality by 4. And we will get that three times AE equals to 12K. Here we will divide this equality by 3, and we will get that AE equals to 12 over 3 is 4. AE equals to 4K, so we actually found out that if AB equals to 3K, then AE must be equal to 4K. Okay? So we will continue to focus on the right triangle, triangle ABE. We know that in the right triangle, triangle ABE, according to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BD square, AB square plus BE square. We are talking about the right triangle ABE, so it is AB square plus BE square must be equal to AE square. Okay, in the right triangle, according to the Pythagoras theorem, AB square plus BE square must be equal to AE square. That is according to the Pythagorean theorem. we have already found out that actually we defined AB as 3K, so AB is 3K, so AB square is 3K square plus BE. What is the value of BE? BE equals to 3 plus 4, that is to say to 7, so it is actually 7 square equals to AE square. We have already found out that AE equals to 4K. So AE square is 4K square. So here 3K square is 9K square plus 7 square is 49. It equals to 16K square. So here we will subtract 9K square from this equality, and we will get that 16 minus 9 is 7, so 7K square equals to 49. K square equals to 49. Here we will divide this equality by 7, and we will get that K square equals to 49 over 7 is 7. K square equals to 7. We will take a root out of this equality, and we will get that K equals to the positive root of 7. K must be positive because it is actually the side of a triangle that it must be a positive number. So K equals to the positive root of 7. So we actually know that AB equals to 3K. AB equals to 3K, and if K equals to root 7, AB actually equals to 3 times root 7 units. AB equals to 3 times root 7 units. And we know that AE equals to 4K. And we know that K equals to root 7, so AE will be equal to 4 times root 7. Okay, so we actually found out the values of AB and AE. Okay, in the next step we will focus on the big right triangle, triangle ABC. We know that in the big right triangle, triangle ABC, tangents 3 alpha equals to BC over AB. In the right big triangle ABC, tangents 3 alpha equals to BC over AB. What is the value of BC? BC equals to 3 plus 4 plus x. That is to say BC equals to 7 plus x. So we substitute BC by 7 plus x. And actually we have already found out that the value of AB is 3 times root 7. Okay, so in total we got that the value of tangents 3 alpha equals to 7 plus x over 3 times root 7. So I will write it down. The value of tangent 3 alpha is 7 plus x over 3 times root 7. In the next step, we will focus on the right triangle, triangle ABE. So, on the right triangle, triangle ABE, we know that tangent 2 alpha equals to BE over AB. In the right triangle, triangle ABE, tangent 2 alpha equals to BE over AB. But what is the value of BE? BE equals to 3 plus 4. That is to say to 7. And we have already found out that AB equals to 3 times root 7. So in total, we got that the tangent 2 alpha equals to 7 over 3 times root 7. Tangent 2 alpha equals to 7 over 3 times root 7. Okay, in the next step, we will focus on the right triangle, triangle ABD. So, in the right triangle, triangle ABD, tangent alpha equals to BD over AB. On the right triangle, triangle ABD, we know that tangent alpha equals to BD over AB. Okay, but what is the value of BD? The value of BD is 3 units. And we have already found out that the value of AB is 3 times root 7 units. So in total we got that the value of tangent alpha equals to 3 over 3 times root 7. Tangent alpha equals to 3 over 3 times root 7. So we actually found out the values of tangent alpha, tangent 2 alpha, and tangent 3 alpha. Okay? But we also know that tangent 3 alpha equals to tangent 2 alpha plus alpha. Okay? Tangent 3 alpha equals to tangent 2 alpha plus alpha. And in order to find out the value of tangent 2 alpha plus alpha, I will present to you a new trigonometric identity that is actually tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A times tangent B. Okay, so according to this trigonometric identity, tangents A plus B equals to tangents A plus tangents B over 1 minus tangents A times tangents B. So we actually can calculate the value of tangents 2 alpha plus alpha according to this trigonometric identity. So we will get that tangents 3 alpha, it actually equals to tangents 2 alpha plus alpha equals to tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangents alpha. So we actually calculated the value of tangents 2 alpha plus alpha according to this trigonometric identity, but we know that the value of tangents 3 alpha equals to 7 plus 6 over 3 times root 7, the value of tangents 2 alpha equals to 7 over 3 times root 7, and the value of tangents alpha equals to 7 over 3 times root 7. So we will substitute the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha by the values that we have already found out for tangents alpha, tangents 2 alpha, and tangents 3 alpha. So we will get that tangents alpha, we have already found out that tangents alpha equals to 7 plus x over 3 times root 7, and that equals to tangents 2 alpha, tangents 2 alpha equals to 7 over 3 times root 7 plus tangents alpha equals to 3 over 3 times root 7, all divided by 1 minus tangents 2 alpha times tangents alpha is 7 over 3 times root 7 times 3 over 3 times root 7. So we actually have this equality after we substituted the value of tangents alpha, tangents 2 alpha, and tangents 3 alpha by the values that we have already found out for that variables. So here we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7 in order to have a common factor with this expression. Okay, and we will get that seven plus x over 3 times root 7 equals to 7 over 3 times root 7 plus 3 over 3 times root 7 . So actually here 7 plus 3 is 10. So I will write down that again 7 plus x over 3 times root 7, 3 plus 7 plus 3 is 10 over 3 times root 7 As I already said, we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7 in order uh, to have the common factor with this expression. So we substituted 1 by this expression equals to 1. Okay, in this way we actually will have a common factor with this expression. So here we have 7 times 3 is 21. So in total we got this expression. So here we will move this expression to the numerator and we will move this expression to the denominator here. Okay. Okay, so we move this expression to the numerator and this expression to the denominator and we got this equality. So here 10 times 3 is 30. First of all, we have here 3 times root 7 in the numerator and we have 3 times root 7 in the denominator, so 3 times root 7 will get cancelled, and what is left after we cancel 3 times root 7? Seven plus x over 3 times root 7 equals to 10 times 3 is 30 times root 7 over here 3 times 3 is 9 and root 7 times root 7 is 7 and 9 times 7 is 63. So in total this expression equals to 63 minus 21. So here 63 minus 21 is 42. So we have this equality. Here we will multiply this equality by 3 times root 7 and we'll get that 7 plus x equals to 3 times root 7 times 30 times root 7 over 42. So 7 plus x equals to 3 times 30 is 90, and root 7 times root 7 is 7, and 90 times 7 is 630 over 42. Okay, so we got this equality. 630 over 42 is 15, equals to 7 plus x. Here we will subtract from this equality 7, and we will get that x equals to 15 minus 7 is 8 units. So we found that the value of x is 8 units. 8 equals to x equals to 8 units. So here we know that x equals to 8 units. We found out that x equals to 8 units. That is actually the value of EC that equals to 8, that equals to 8 units. Okay, so we finished with the first method to find out the value of x. So in the next step I will present to you a second method to find out the value of x. Okay, so we will extend BD by 3 units. And we will define this point as point M. Actually, MB equals to 3 units because we extended BD by 3 units, therefore MB equals to 3 units. And we will join together points A and M by a straight line. So actually we have here triangle ABM, and what is the size of this angle? We know that MD is a straight line because BD was a straight line, and as a side of triangle is a straight line. So, and we extended BD by 3 units, so it remains a straight line. Okay, BD is a straight line, and we have a rule that states that the sum of the angles on a straight line is equal 280 degrees. I will read the rule again. The rule states that the sum of the angles on a straight line is equal to 180 degrees. And we know that MD is a straight line. We know that MD is a straight line. Therefore, the sum of the angles on the straight line MD at any point on the straight line MD must be equal to 180 degrees. And especially at point B, the sum of the angles on the straight line MD at point B must be equal to 180 degrees. So what we have at point B, which angles we have at point B? At point B, we have a right angle. This angle equals to 90 degrees. So we have 90 degrees plus the size of this angle, that is actually angle ABM, must be equal to 180 degrees according to this rule. The sum of the angles at point B on the straight line MD must be equal to 180 degrees. That is to say 90 degrees plus the size of angle ABM must be equal to 180 degrees. Okay? So the sum of the angles at point B on the straight line MD must be equal to 180 degrees. That is to say 90 degrees plus the size of angle ABM must be equal to 180 degrees. Here we will subtract from this equality 90 degrees, and we will get that the size of angle ABM equals to 180 degrees minus 90 degrees is 90 degrees. We found out that angle ABM is a right angle. It equals to 90 degrees. So in the next step we will focus on triangles ABD, the right triangle ABD and the right triangle ABM. Okay, on those two right triangles. Okay, so on those two triangles, we know that MB equals to BD equals to 3 units. MB equals to BD equals to 3 units. MB equals to 3 units according to our construction, and BD equals to 3 units. That is what is given us in the question. So MB equals to BD equals to 3 units. We also know that those two angles are equal to each other. They are both right angles. So angle ABM equals to angle ABD equals to 90 degrees. Angle ABM equals to angle ABD. They are both right angles. They are equal to 90 degrees. And we also know that AB is a common side, so AB equals to AB. It belongs to both triangles. AB equals to AB, a common side. It belongs to both triangles. Okay, so AB equals to AB. So we actually proved that the right triangle ABD congruent to the right triangle ABM according to side angle side rule. So I'll write it down. Triangle ABD congruent. This is the sign of congruent to triangle ABM according to side angle side rule. According to side angle side rule. Okay, the right triangle ABD congruent to the right triangle ABM according to side rule. According to side angle side rule. So what is side angle side rule? Side angle side rule is if you prove that one triangle, the two sides and the angle between those two sides in one triangle are equal to two sides and the angle between them in the other triangle, then you proved that those two triangles can go into each other according to side angle side rule. And we proved that in triangle, the right triangle AMB, sides AB and MB and the angle between them are equal to AB and BD and the angle between them in the right triangle ABD. Therefore, those two triangles can go into each other according to side angle side rule. So from the fact that those two triangles can go into each other, we can derive that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other. Therefore, the corresponding angles will be also equal to each other. Okay, so I write it down. Angle ABD that equals to alpha will be equal to angle BAD that equals to alpha angle BAD that equals to alpha will be equal to angle BAM on the right triangle ABM. Okay, angle BAD that equals to alpha will be equal to angle BAM in triangle BAM. According to the rule that corresponding angles in congruent triangles are equal to each other. Again, angle BAD equals to angle BAM. According to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding angles must be also equal to each other. So if angle BAD is alpha according to this equality, angle BAM will be also equal to alpha. And we also can conclude from the fact that those two triangles congruent to each other that AM equals to AD. AM equals to AD. According to the rule that corresponding sides in congruent triangles are equal to each other. Again, AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, those two triangles congruent to each other, therefore the corresponding sides that are AM and AD will be also equal to each other. Okay, and if we define side AM as Y, then side AD that equals to AM will be also equal to Y. Okay, here AM equals to AD equals to Y. Okay, so in the next step we will focus on triangle ADC. On triangle ADC, in triangle ADC, we know that AE is angle bisector in triangle ADC. AE is angle bisector. Again, in triangle ADC, AE is angle bisector. Again, in triangle ADC, AE is angle bisector. Why AE is angle bisector in triangle ADC? Because of the fact that AE divides angle DAC to two equal parts, to alpha and alpha. It bisects angle DAC, therefore AE is angle bisector in triangle DAC. And according to the rule of angle bisector or angle bisector theorem. The angle bisector AE divides side DC in a ratio that equals to DE and over EC. DE over EC is the ratio that angle bisector AE divides side DC of the triangle DAC. And that ratio equals to the ratio between the angle legs. And the angle legs are AD and AC. Okay, so it equals to AD over AC. So the ratio between the angle legs, that is AD over AC, equals to the ratio that angle bisector AE divides side DC, and that ratio is actually DE over EC. Okay, the ratio that angle bisector AE divides side DC of the triangle ADC is DE over EC, and that ratio equals to the ratio between the angle legs, and the ratio between the angle legs is AD over AC, so those two ratios are equal to each other. Okay. And what is the value of DE? DE equals to 4 units. What is the value of EC? EC equals to X. What is the value of AD? AD equals to Y over AC. So we got that 4 over X equals to Y over AC. Here we will multiply this equality by AC. We will get that 4 over X times AC equals to Y. We will multiply this equality by X, and we will get that 4 times AC equals to Y times X. Here we will divide the equation number 1 by 4 in order to get the value of AC. And we will get that the value of AC equals to Y times X over 4. That is equation number 1 for AC. So we found out that AC equals to Y times X over 4. So in the next step we will focus on the big triangle, triangle AMC. In triangle AMC, we know that AD is angle bisector. AD is angle bisector. Okay, in the right, the big triangle AMC, AD is angle bisector. Why AD is angle bisector in the big triangle AMC? Because of the fact that AD divides angle MAC to 2 equal parts. So this is the first part, and this is the second part. Okay, so here we have, it divides angle MAC to 2 alpha and 2 alpha. Because of the fact that angle bisector AD divides angle MAC to 2 equal parts, that is the reason that it is defined, AD is defined as angle bisector, because it bisects angle MAC to 2 alpha and 2 alpha. Okay, so according to angle bisector theorem, the angle bisector AD divides side MC in a ratio of MD over DC. MD over DC, that is the ratio that angle bisector AD divides side MC, and that ratio equals to the ratio between the angle lengths, and the ratio between the angle lengths is AM over AC. Again, angle bisector AD divides side MC in a ratio of MD over DC, and that ratio equals to the ratio between the angle lengths, and the ratio between the angle lengths is AM over AC. So those two ratios are equal to each other. The ratio that angle bisector AD divides MC equals to the ratio between the angle lengths, that is AM over AC. So those two ratios are equal to each other according to angle bisector theorem. So what is the value of MD? The value of MD is actually MD equals to 3 plus 3. That is to say to 6. What is the value of DC? DC equals to 4 plus X. DC equals to 4 plus X. All equal to AM. What is the value of AM? AM equals to Y according to our definition. Okay, so we got equation number 2 that says that 6 over 4 plus X is equals to Y over AC. Here we will multiply this equality by AC, and we will get that AC times 6 over 4 plus X equals to Y. That is what we got after we multiplied the equation by AC. Here we will multiply equation number 2 by 4 plus X. So 6 times AC equals to Y times 4 plus X. We will divide equation number 2 by 6 in order to get the value of AC. And we will get that AC equals to Y times 4 plus X over 6. That is the value of AC according to equation number 2, and we have already got the value of AC in equation number 1. According to equation number 1, AC equals to Y times X over 4. So we have the value of AC in equation number 1 and equation number 2. In the next step we will create equation number 3, that is actually the equality that AC equals to AC. Okay, AC equals to AC. We will substitute AC in this side of the equality by the value of AC in equation number 1, and on the other side of the equation number 3 we will substitute AC by the value of AC according to equation number 2, and we will get that AC according to equation number 1 is y times x over 4, and AC according to equation number 2 is 1y times 4 plus x over 4. Okay, according y times 4 plus x over 6. Y times 4 plus x over 6, that is the value of AC according to equation number 2. Here we will divide this equation number 3 by y, and we will get that x over 4 equals to 4 plus x over 6. So here we will multiply equation number 3 by 4 and 6, and we will get that 6x equals to 4 times 4 plus x. We will open the brackets in equation number 3. We get that 6x equals to 16 plus 4x. So here we will subtract 4x from equation number 3, and we will get that 2x equals to 16. X equals to 16. We will divide the equation number 3 by 2, and we will get that x equals to 8 units. So we found out that the value of x is 8 units. Okay, so the value of EC that equals to x is 8 units. Okay, so in the next step I will summarize the lecture. Okay. So we actually wanted to find out the value of x And we know that triangle ABC is a right triangle. Angle ABC equals to 90 degrees. We know that BD equals to 3 units, DE equals to 4 units, and angle ABD equals to alpha, angle AD equals to alpha, and angle EAC equals to alpha. And we want to find out the value of X, that is actually also EC. So, in order to find out the value of X, I presented to you the angle bisector theorem. According to angle bisector theorem, an angle bisector divides the side it hits in a ratio that equal to the ratio of the angle legs. So, in triangle ABC, AD is angle bisector, YAD is angle bisector, because it bisects angle BAC, or it divides angle BAC to two equal parts, that is to say to theta and theta. Therefore, AD is angle bisector of triangle ABC. And according to angle bisector theorem, the angle bisector AD divides the side that it hits. Angle bisector AD hits side BC of triangle ABC, and it divides it in a ratio of BD over DC. Okay? Or angle bisector AD, if you look it in this side, angle bisector AD divides side BC in a ratio of DC over BD. Again, angle bisector AD divides side BC in a ratio of DC over DB, and that ratio equals to the ratio between the angle legs. The ratio between the angle legs is AC over AB, or the ratio that angle bisector AD divides BC is DC over DB, and that ratio equals to the ratio between the angle legs, that is actually AC over AB. Okay, the ratio that angle bisector divides BC equals to the ratio between the angle legs. That's all. Okay, so we focused on triangle ABE. On the right triangle ABE, and in the right triangle ABE, AD is angle bisector. Why AD is angle bisector? Because of the fact that it divides angle BAC to two equal parts, alpha and alpha. Okay, therefore AD is angle bisector on the right triangle BAE, and according to angle bisector theorem, the ratio that angle bisector AD divides BE is BD over DE, and that ratio equals to the ratio between the angle legs, equals to AB over AE. Okay, so BD over DE, that is the ratio that angle bisector AD divides BE, and that ratio equals to the ratio between the angle the x, that is AB over AE. Okay, but what is the value of BD? BD equals to 3 and DE equals to 4. So in total, BD equals to 3 and DE equals to 4. So we got that AB over AE equals to 3 over 4. And if we define AB as 3K, we will get that the value of AE, if AB equals to 3K, then the value of AE will be equal to what we will get after we will substitute AB by 3K. We substituted AB by 3K, and from this equality we got that AE equals to 4K. So if AB equals to 3K, then AE will be equal to 4K. Okay, then we continue to focus on the right triangle ABE. On the right triangle ABE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AB square plus BE square equals to AE square. AB square plus BE square equals to AE square. We know that AB equals to 3K. BE equals to 3 plus 4, that is 7. And AE equals to 4K. So we got this equality that 3K square plus 7 square equals to 4K square, and 3K square is 9K square, 7 square is 49, 4K square is 16K square. And we solved this equality and we found out that we have only one variable missing, that is K, and we found out that K equals to root 7 unit to the positive root of 7, and we know that 3K equals to AB equals to 3K, so we substitute that K by its value here, and so AB equals to 3 times root 3, and here that A equals to 4K, and we know that K equals to root 7, that is to say AE will be equal to 4 times root 7. So we found out the values of AB and AE. Then we focus on the right triangle ABC. We know that tangent 3 alpha equals to BC over AB. BC equals to 7 plus X, and AB equals to 3 times root 7. So in total we got that the value of tangent 3 alpha is 7 plus X over 3 times root 7. Then in the right triangle ABE, we know that tangent 2 alpha equals to BE over AB. In the right triangle ABE, we know that tangent 2 alpha equals to BE over AB. We know that BE equals to 7 units, and AB equals to 3 times root 7. So in total, we got that the tangent 2 alpha equals to 7 over 3 times root 7. Then we focused on the right triangle ABD, and the right triangle ABD, we know that tangent alpha equals to BD over AB. Tangent alpha equals to BD over AB. We know that BD equals to 3 units and AB equals to 3 times root 7. So in total we got that tangent alpha equals to 3 times 3 over 3 times root 7. So we found out the values of tangent alpha, tangent 2 alpha and tangent 3 alpha. And we also know that tangent 3 alpha equals to tangent 2 alpha plus alpha. And in order to find out the value of tangent 2 alpha plus alpha, I presented to you a new trigonometric identity. The trigonometric identity is tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A times tangent B. And we found out the value of tangents to alpha plus alpha according to this trigonometric identity, and found out that the value of tangents to alpha plus alpha is tangents to alpha plus tangents alpha over 1 minus tangents to alpha times tangents alpha. Okay, but we have already found out the values of tangents 3 alpha, tangents 2 alpha, and tangents alpha. So we substituted the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha by the values that we have already found for those variables, and we got this equality. We have only one variable that is missing in this equality, that is x. We solved this equality and we found out that the value of x is actually 8 units. X equals to 8 units. That is to say, EC that equals to x equals to 8 units. Okay, that was the first method. And in the second method, we found x in the second method. In the second method, we extended side BD by 3 units, and we defined this point as point M because of the fact that we extended BD by 3 units. MB will be equal to 3 units, and then we connected together points M and A by a straight line, and actually then we found this angle. According to the rule, we know that MD is a straight line, and we know the rule that the sum of the angles on a straight line equals to 180 degrees. So the sum of the angles of the straight line MD must be equal to 180 degrees at any point, and especially at point B on the straight line MD, the sum of the angles must be equal to 180 degrees. Okay, and what angles we have at point B? We have here right angle. We know that this angle equals to 90 degrees, and we have this angle. So according to this rule, 90 degrees plus the size of angle ABM must be equal to 180 degrees. We subtracted 90 degrees from this equality, and we got the value of the size of angle ABM. ABM equals to 90 degrees. So this angle is a right angle. Then we proved that those two right angles, triangle ABM and triangle ABD, can go into each other. Why? First of all, we have MB equals to BD equals to 3 units. MB equals to 3 units according to our construction. We extended BD by 3 units, therefore MB equals to 3 units. So MB equals to BD equals to 3 units. We also know that those two angles are equal to each other, they are both right angles. So angle ABM equals to angle ABD equals to 90 degrees. And we also know that AB equals to AB. AB is the common side, it belongs to both triangles. Therefore, AB equals to AB. And we actually proved that those two triangles can go into each other according to side angle side rule. What is side angle side rule? If you prove that two sides and the angle between them in one triangle are equal to two sides and the angle between them on the other triangle, then you proved that those two triangles can go into each other according to side angle side rule. Okay, so those two triangles can go into each other, therefore we can derive from the fact that those two triangles can go into each other that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So we know that angle BAD equals to alpha, therefore angle MAB that equals to angle BAD must be also equal to alpha. And we also can conclude from the fact that those two triangles can go to each other, that AM, side AM equals to side AD, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go to each other, therefore the corresponding sides, that is to say AM and AD, must be also equal to each other. So if AM is y, then AD must be also equal to y, because they are equal to each other. Okay? And then we focused on triangle ADC. On triangle ADC, we know that AE is angle bisector. AE is angle bisector on triangle ADC. Why AE is angle bisector on triangle ADC? Because of the fact that it bisects angle DAC. It divides angle DAC to two equal parts, to alpha and alpha. Therefore, AE is angle bisector on triangle ADC. And according to angle bisector theorem, the ratio that angle bisector AE divides side DC is DE over AC. And that ratio equals to the ratio between the angle legs, that is actually AD over AC. Okay? The ratio that angle bisector AE divides DC is DE over AC, and that ratio equals to the ratio between the angle legs, that is to say AD over AC, because the ratio between the angle legs is AD over AC. So those two ratios are equal to each other. What is the value of ED? ED equals to 4 units. What is the value of EC? EC equals to X. What is the value of AD? AD equals to Y over AC. So in total we got this equality, equation number 1. We multiply this equality, equation number 1, by AC. We got this equality, and then we multiply it by X, and then we divide it by 4, and we got that the value of AC is Y times X over 4. Then we focused on the big triangle, triangle AMC. We know that AD is angle bisector on the big triangle, triangle AMC. Why AD is angle bisector? Because it bisects angle MAC to two equal parts, 2 alpha and 2 alpha. Therefore, AD is angle bisector in triangle AMC, and according to angle bisector theorem, the angle bisector AD divides side MC to in a ratio that equals to MD over DC. And that ratio equals to the ratio between the angle legs, that is to say to AM over AC. So the ratio that angle bisector AD divides MC is MD over DC, and that ratio equals to the ratio between the angle legs, that is AM over AC. We know that MD equals to 3 plus 3 is 6. DC equals to 4 plus X. AM equals to Y. So in total we got this equality. And we found out, according to equation number 2, that AC equals to Y times 4 plus X over 6, and we know that AC equals to Y times X over 4. So we have two equations from AC, and then we created equation number 1 that states that AC equals to AC. And we substituted AC in this side of the equality by the value of AC in equation number 1, and we substituted AC in this side of the equality by the value of AC in equation number 2. We got this equality, we divided this equality by Y. We have only one variable that is missing. We found the value of X. We found that X equals to 8 units. Okay? So here AC that equals to X equals to 8 units. Okay? So in both methods we found that the value of EC that is actually X is equal to 8 units. Okay? Thank you very much.